So, now see here some important terms used in magnetism. First term is here magnetizing intensity or magnetizing force. So, see here, if you have taken here the solenoid like this, or you can say even the toroid you can take, some material is placed inside it. If the current is flowing through this solenoid, suppose is I, and the solenoid has got the number of turns per unit length, that is N, then magnetic field inside this material which is being magnetized here actually, that can be written B is equal to mu N I. Mu is the permeability of the material which has to be magnetized. So, here N I is known as magnetizing intensity or magnetizing force. So, we can write here B is equal to mu H. So, the degree to which a magnetic field can magnetize a material is represented in terms of the magnetizing intensity. If the solenoid is suppose in the free space and magnetization is taking place, then we can write here B is equal to B naught is equal to mu naught H, and here this is for the free space. So, this is about magnetizing intensity or magnetizing force. Let us take the second term. Second term is here, or the second terminology used, that is called intensity of magnetization. So, second one is here intensity of magnetization or only magnetization you can say. Here this is represented by, here I am represented by I here, representing here by I, that is a vector quantity here. This is actually here the total magnetic dipole moment divided by here per unit volume. So, when a material is magnetized by using the magnetizing intensity H, it gets magnetized, and so the new magnetic dipole moment per unit volume is referred as intensity of magnetization or just magnetization. So, this is about it, this is also the vector quantity, and we can also write here I is equal to m, this is the total magnetic dipole moment, that can be written here m into 2L divided by A into 2L. This is the total volume, that will get cancelled here, and so here we can write m upon A, that is the pole strength per unit area. So, magnetic pole strength per unit area is actually known as intensity of magnetization. So, now see a magnetic susceptibility which is represented by chi m. Chi m is actually is equal to I upon H, that is the total magnetic field induced divided by magnetizing force. It is the ratio of these two I and H. So, these I and H have got the same unit. So, chi m has no unit, it is just a number, but it actually tells how easily a material can be magnetized, where I tells here till what extent a material can be magnetized. So, this is actually the chi m, which is a dimensionless quantity, has that means has no unit, and basically it is represented or equal to I upon H. Now, see here relative magnetic permeability of material. It is defined as the ratio of number of magnetic field lines per unit area in that material to the number of magnetic field lines per unit area that would be present if the medium were replaced by a vacuum. So, that is written actually B upon B naught. So, this is the relative magnetic permeability of the medium. So, mu r has actually no unit here. This can be also written mu h upon mu naught h, this can be cancelled here. So, we can write mu is equal to mu naught mu r. So, here mu r is the relative magnetic permeability of the medium, whereas mu is the permeability of the medium. So, by using this relation also we can get the magnetic permeability of the medium.